I'm Nick Beaird. I'm from Oregon State University, and I'm a physical oceanographer, so that means I study ocean physics. And here I'm trying to understand the part of the dynamic Arctic that is related to physical dynamics. So what are the physical processes that are at play in the Arctic that are relevant to biology and chemistry? So how do things like winds, wind-induced currents, tides, mixing, how do they move around nutrients, properties, phytoplankton, and what might their effect be on the ecosystems that we're interested in around here. So I brought a few different instruments. The two categories of things we're measuring are currents, so velocity, and temperature. And the velocity I'm measuring in a couple of different ways. So I have some sensors that use acoustic Doppler measurements to get a profile of velocity over about 50 meters in the water column. So this is a sort of medium scale look at the ocean. And I also have a little instrument that measures velocity in a really small scale, so over about 30 centimeters to a meter, and it tells you something about the little turbulent eddies that are at work on the small scales that are related to the kind of turbulence that mixes up the water column and can potentially transport nutrients around. The basic idea is that we're taking measurements of the physical environment that is impacting the biogeochemistry of the region. I ended up being a physics and math major in college. And when I got towards the end of college, I wanted to keep doing academics. I was pretty interested in it, but I thought it'd be fun to go outside and do some kind of physics where you get to do field work. And oceanography was one avenue to do that, where I knew there was a lot of field work, but we still got to apply physical principles and think about the physics of rotating fluids and some interesting fluid mechanics problems, but we also got to come out to cool places like this. What really got me passionate about science was some really fantastic teachers that I had in high school and also in college that sparked my interest in doing physics and really led me in a different direction than I expected to go. One of the ideas is to use the data in combination with all of the neat biogeochemistry data that's being taken to try to understand how physics, how the physical processes are transporting nutrients and are affecting the ecosystem, and try to identify what causes some of those things. And then ultimately, in some really big picture sense, if we understand what's happening now, can we understand how those things might change in a world where, or in a sea where there's less ice? So I think that's one of the big themes probably of a lot of people's work here, is trying to understand how, as these big changes, big environmental changes are happening here, what's the response going to look like? I would say to continue to be open to new subjects and ideas. You'd be surprised how late you can decide that something's really interesting. And that, I think, staying open and thinking about being curious about different fields, different ideas, different paths of study forever, basically. Always being interested in learning something new might lead you in a direction that's fun and that you didn't expect.